In this example, we have to solve the initial value problem. Remember, an initial value problem is given by a differential equation and a condition. Remember, this condition here, y at 1 is equal to 4e minus 3 is equivalent to the pair 1 comma 4e minus 3, right? Okay, well, first of all, we have to find the solution of the differential equation, and it is convenient to write the equation like this: dy dx minus 1 over x y equals to 4x e to the x. So since it is a linear, then this term here is equivalent to p of x, and this term here is equivalent to q of x. And then, since it is linear, we can find the integrating factor, and then once we find the integrating factor, we multiply the whole equation by the integrating factor. The same operation we did in the previous example. So we have that our integrating factor is e to the integral of p of x dx. So in this occasion, we can have e to negative integral of 1 over x dx, which is e to the integral of 1 over x is ln of x, and then this is equivalent to, oh well, negative here missing, this is equivalent to e to ln of x negative 1, which is x negative 1, and then finally 1 over x, provided that x is positive number, because remember, the domain of a logarithmic function must be the set of the real positive numbers. So now we multiply the whole equation. Our whole equation is dy dx minus 1 over x y equals to 4x e to the x times the integrating factor, which is 1 over x. So once we multiply everything by the integrating factor, we're going to have an equation: 1 over x dy dx minus 1 over x to the second y equals to 4e to the x. And then, as in the previous example, this portion that I'm shading now in pink, this is the product rule, the result of applying the derivative on a product. The product is going to be the integrating factor and the and y. So it's going to be 1 over x times y, or y times 1 over x is the same thing, equals to 4e to the x. So remember, we're solving a differential equation. Solving a differential equation means that we have to apply integral. So in order to get rid of the derivative, this prime, which is a sign of derivative, so we apply integration on both sides. So we have integral cancel derivative, so we have 1 over x times y equals to the integral of 4e to the x, which is exactly 4e to the x plus a constant c. Now we need to isolate y. Then we're going to multiply everything by x. So our new equation would be, our solution is going to be 4x e to the x plus cx. So that is our general solution. Now, remember, we're given a condition which is 1, comma, 4e to negative 3 in order to find the value of c, which is solving the initial value problem. So we have 4e minus 3 equals to 4 times 1 times e to 1 plus c times 1. So this term will cancel this, 2 of the same. And then we have negative 3 equals c. So our solution is, final solution would be y equals to 4x e to the x minus 3.